Okay, this video set is for Chapter 6, Geometry. It's page 59 of your workbook, so be sure to take notes on the things that you need to. You'll be doing lots of classwork with this one. We'll probably skip some things as well. It starts off with properties of angles. So read through this, read through your book. If you're not familiar, we don't do too much with that, but you do need to know about supplementary and complementary angles, and that supplementary, they'll add up to 180 degrees, and complementary adds up to 90 degrees. So now we're moving on to page 60. Here's some examples of each of the types of angles. The book does a really good job of just showing you about this, so I'm not going to go through a lot of this. Triangles we will use in the problem-solving unit, and some of the word problems in geometry will want you to know that the angles of a triangle are going to add up to 180 degrees. On page 61, you see the different types of triangles: scalene, equilateral, isosceles. So it's important to reference back to that for some of the word problems. Right triangles are important. We use those a lot as well. Now we're going to get into some word problems here. Pretty simple ones to start with. A triangle has two angles that measure 35 degrees and 75 degrees. Find the measure of the third angle. So if we know that the angles need to add up to 180 degrees, we can say let x equal the third angle. And we'll just set up the equation as 35 plus 75 plus x equals 180. I'll go ahead and you can pause the video if you want and work out the numbers there, but pretty quickly we'll just have 110 plus x equals 180, so just a little quick algebra review. Then x will equal, if we subtract 110 from both sides, we're going to have x equals 70, and we would write that in degrees. I'll leave this next problem as a classwork for you to own. You'll get the answers to the classwork. I think I'll just put them at the bottom of your assignment page. Now we're going to move on to the Pythagorean theorem. Hopefully you're familiar with this. It may have been a while since you've used it, but the thing to know here is the longest side is your hypotenuse. So we'll just kind of align that in red here. That's your hypotenuse. So that's always directly across from the 90-degree angle. The other two, it doesn't really matter which one you call A or which one you call B. Now let's take a look at example 6.5 on page 63 of your workbook. This one is very straightforward. You just write the formula, plug in your values, and figure out C. Use the square root button on your calculator. 6.6. Same thing, you just have to be careful because you're solving for side B not C. So you're going to need to use a little algebra, and I'll show you that work in this word problem. So actually this one here, 6.6, I'll leave as a classwork. You can skip the one above if you'd like to, but feel free to do it if you want. We'll do 6.7 as an example together. So a sailboat has a large sail in the shape of a right triangle. The longest edge of the sail measures 17 yards and the bottom edge of the sail is 8 yards. How tall is the sail? So we're going to just do a little drawing here. Doesn't need to be to scale, but we know this will be our right triangle, so you do want to mark that. Now it tells me the longest edge is 17 yards, and I do know that my hypotenuse is always the longest. So I'm going to mark that as 17 yards. My shortest bottom edge is 8 yards. I think it's the shortest, knowing about sails. And then this edge that we're trying to find, we can just call it B to match the diagram that we're given with the formula if we want. So then we're going to have our formula, a squared plus b squared equals c squared. So go ahead and write that out. You always want to write the formula each time. We're trying to find side B. It's pretty straightforward what that side is. Then we're going to go ahead and fill in a squared plus the b we don't know. You can put in x if you'd like. And then c is 17. And that's squared. Now we'll just crunch the numbers. Plus b squared, you can just use your calculator to get 289. I'm going to subtract 64 from both sides here. So b squared equals 225. But we're not quite done. We need to take the square root of that number. So just use the square root key on your calculator. It's right above your square key, if you don't know where that is. And then b is going to be 15. Now square root, when we have b squared, we're really taking the square root of both sides to solve for that, and usually we have a plus or minus situation in that case. However, we're talking about length, so we'll just write the positive root, principal root, and then I'm going to just write out the answer in a sentence. The sail is 15 yards tall. And I am finished with that problem. Next, we're moving on to page 64 of your workbook for similar triangles. Two triangles are congruent if they are exactly the same size and shape. In congruent triangles, the measures of corresponding angles and the lengths of corresponding sides are equal. So here are two triangles that I'll do for an example, and then you can do the next problem as classwork. So we're going to set this up as 66 feet. So we just need to be careful that we set our ratio on each side to match. So we have 66 feet here is to X feet. Set that equal in a proportion to then the 42 feet. So I have the left side triangle, the larger one, those dimensions are on the top. And then now that matches up to 35 feet. It's in the corresponding position, corresponding lengths. Now I can use what's called cross multiplication to solve this. So I'm actually going to do that up above over here. So we have 42x equals 66 times 35. Divide both sides by 42 to solve. And now we get x is equal to 55, and that the dimensions are in feet. It's not really a word problem, so we'll just leave it as that. Don't need to really write a sentence for that one. Just to note that you can only do cross multiplication across an equal sign when you have one fraction set equal to another. We also want to just double check that our answer makes sense. 55 feet makes sense here, that it would be smaller than the 66 on the left triangle, but bigger than the 35 feet on the right triangle. So now we're going to move up to example 6.9, and that one will be a classwork for you to go ahead and turn in. Now your workbook has several other shapes and formulas that you can look through as